All right, you guys, we'll do a recording here for lesson 4.5. And this is page 306 in your book. Now, when you have to graph these things in the same coordinate plane and you just on notebook paper, not using decimals and things, we'll see how well I can do this here. Okay, so I'm looking at problems like 31, okay? So it has f of x is negative 2 sine x. And it has g of x is equal to 4 sine x. Now, to make this, and mine's going to be a little bit sloppy, but I know I need to go from negative 4 to 4 for the second one. So when I'm doing the first one, f of x, I'm supposed to do 2 full cycles. So I'll do 1 negative and 1 positive. All right, I know because b is 1 that this is going to be 2 pi. So this will be negative 2 pi. So then this is pi, here's negative pi. So this is pi over 2, 3 pi over 2, and so on. All right, sine starts out at 0. At pi over 2, instead of this being positive 2, now it's going to be negative 2. And the opposite here at 3 pi over 2, instead of negative, now it's going to be at positive. So there's one cycle of f of x. Now, same thing happens here. At negative pi over 2 again, this thing's going to go, so 3 pi over 2 and negative pi over 2 will have the same height, and this one will be the same. So doesn't this one go from negative 2 to 2? And the period is 2 pi. All right, 4 sine x. Let's see, can I do this in a different color? Where's my pen? I don't want that. All right, so 4 sine x starts out at 0. Oops, back to the pen. At pi over 2, it hits its peak of 4. At pi, it's at 0. At 3 pi over 2, it's down here at negative 4. So that one looks like that. So both of them are going to be the same. So this one looks like that. So we'll get both of those graphs for 31. All right, let's go to a new screen. Let's suppose now I jump down to number 39. How do I graph y equals 5 sine x? Okay, whoops. I know the amplitude is 5, so I know my range is going to go negative 5 to 5. Okay, my period is 2 pi over b, so my period is going to be 2 pi. So if I'm supposed to do 2 full cycles of the graph, okay, okay, and here I'm going to do 2 cycles on this side. So there's 2 pi and there's 4 pi. Let's suppose I also want to go 3 cycles and I go there. All right, so then here's pi, here's 3 pi. Pi over 2, 3 pi over 2. So I put these into fours. All right, sine starts out, okay, at pi over 2, it's at its peak. At pi, it's here. At 3 pi over 2, it's at its min. There's one cycle. Okay, 1/4 of the way at its peak, 1/2 of the way, 3/4 of the way. There's 2 cycles. Now, what if I had to give you this ordered pair? Well, obviously that's 2 and 3/4. So there's 3 pi, so that's 3.5 pi. So that would be 7 pi over 2 comma negative 5 if I did that on decimals. Okay, let's do a couple more here. 41, 1/3 cosine x. Okay, now, if I put 1 up there, I'm going to put 1/3 there. There's negative 1 and there's 1. Okay, 2 cycles. There's 4 pi. There's 2 pi. So there's pi, 3 pi, so I need all of these fourths. Okay, cosine start out at its peak. The amplitude, this is going to go negative 1/3 to 1/3, and cosine starts out at its peak. 1/4 of the way, halfway there it's at its min, 3/4 of the way. There's 1 cycle. This is negative 1/3 and this is positive 1/3. Okay, do another cycle. It should be up a little higher. So again, I'm getting back to where this is. So this would be 4 pi comma 1/3. Okay. Now, what about 45? This is a little different. Cosine 2 pi x. All right, amplitude is 1. Okay, now the period is 2 pi over the coefficient in front here, in front of the x. So my period is regular units. So now when I make, let me erase that. When I make my x-axis, instead of going in multiples of pi, I'm going to go regular units. So there's 1 and there's 2. And there's negative 1. So here's the splitting it into 4. Now, the cosine, there's a 1 out front, so it's going to go negative 1 to 1. And it starts out here, 1/4 of the way, and this is a little bit high here. 1/2 of the way, 3/4 of the way. Now you guys, notice that instead of being in multiples of pi, this is in regular units. So there's 1.5, 1.25, 1 3/4. And there's 2 cycles. So this ordered pair right here is 1 comma 1. Now, if I did the cosine of 2 pi times 1, the cosine of 2 pi is the same as the cosine of 0, which is 1. So doesn't that repeat every 1 unit, and that's the period? Okay. What about 49? 3 cosine, 3 cosine x plus pi. All right, I'm going to graph, first of all, 3 cosine x. And then I'm going to move it left pi units after I get done. All right. So the period is 2 pi over 1, which is 2 pi. The range is going to go negative 3 to 3. All right, so here is 2 pi right here. And let's make this 4 pi over here. So this is pi, and here's 3 pi. So I need to have this in quarters, right? So normally cosine starts out at its peak. Now remember, I'm graphing this one first. And I'll just do a dot to dot here. Okay, so then 1/4 of the way, halfway it's at its min, 3/4 of the way right there. Okay, now let's go back this way. Here's negative 2 pi. Here's negative pi. So when I do this one, this would be at its peak. 1/4 of the way, halfway. So the dots here. Okay, now I'm going to take every dot and move it to the right, to the left pi units. So this dot, here's negative pi right here. So this one goes left. Okay, so let me scratch this one out. Okay, there's 2 cycles. Now go left pi. So This one was pi right here, so that's gonna be, so left pi, this one's gonna be right there. This one's left pi, so it's gonna lag behind. Okay, so doesn't this go from negative pi to pi one cycle? So I think you can just see that you do the same graph and then move it left. When you get to some of these other ones, let's do one more here. Let's do number 51, where it says sine x minus pi over 2. Pretty easy here one. Now, when I do the sine curve, I'll just do one cycle for now. Okay, actually, let's go back to negative pi. So sine always looks like this. And then this would be like this. Now, move it right, pi over 2. So this point gets moved right, pi over 2. This one gets moved right, pi over 2. That one gets moved right, pi over 2. Okay, this one gets moved right, pi over 2. That one gets moved right, pi over 2. I kind of missed there. Now this would be kind of neat because this is the same as the opposite of cosine x. Wouldn't this be the opposite of the cosine curve right here? Well, this is going to be an identity that we prove later, that the sine of x minus pi over 2 is the same as minus cosine x. Well, hopefully that video will help you start drawing some of these graphs, and we'll have to get some practice at this.